Okay, so the next problem I want to do is number 6. So we have y double prime plus 4y prime plus 4y is equal to 0. And we have two functions. So y sub 1 is e to the negative 2x, and y sub 2 is xe to the negative 2x. So notice e to the negative 2x is coming up a lot. It's a very important exponential function that you'll keep seeing over and over again. So let's verify that these two are in fact solutions to this given differential equation. So let's start with y1. So we have e to the negative 2x, second derivative, plus 4 e to the negative 2x, take the first derivative, plus 4 e to the negative 2x, right? And we're hoping that will give us 0. Well, it should give us 0 because it says verify again, not determine. So remember, you're taking the second derivative of e to the negative 2x. So you're really saying, I have this function, I'm going to take the derivative of it, and then after I take the derivative of it and I simplify, I'm going to take the derivative again because you have two primes. Plus 4, and I'll go ahead and I won't write the derivative yet, just so I can start taking the derivatives one time. So 4e to the negative 2x, again, hopefully give us 0. Okay, so the first derivative of e to the negative 2x is, we know already, is negative 2e to the negative 2x. Okay, I use the chain rule, but I still have to take the derivative one more time. And actually, just to be consistent, let me go ahead and write the brackets. Plus 4 times, well, what's the derivative of e to the negative 2x? Well, we just took it. It's right here. So that's times negative 2e to the negative 2x, and no derivatives here. And, whoops, one more derivative. So the derivative, again, of this guy, so we have to write negative 2 because it's just there, so we have to bring it down. So is e to the negative 2x, again, times the derivative of the inside function, which again is negative 2. And no more derivatives, but these guys, right, that's 8, negative 8. That's an x plus 4e to the negative 2x equals, hopefully, 0. Let's see, we have negative, negative, so we have positive 4e to the negative 2x. Oh, these are nice. These are like terms, right? Negative 8e to the negative 2x plus 4e to the negative 2x is minus 4e to the negative 2x. And that does give us 0 because these guys are gone. So again, oh no. So there's our solution, and again, we say y1, therefore y1 is a solution to the differential equation above. So now let's do the same thing with the second part, or the second function. So xe to the negative 2x. So let's see. Let me make this smaller so I don't have to keep scrolling. So let me write this maybe in green. So I'm moving on to y2, and we have xe to the negative 2x double prime plus 4xe to the negative 2x 1 prime plus 4 x e to the negative 2x. And we're hoping that will give us 0. And so again, these are my y2's from above. So again, we are going to, let's see, let's do this in pieces, because I write really big. And so let's just call this, let's see, part 1, part 2, okay, part 3, there's really nothing to do in part 3. There's no derivatives to take. So, okay, so let's go ahead and take the derivative and the second derivative, but notice I'm going to do I'm going to do part 2 first, because in part 1 I'm going to have to take the first derivative to get the second. So let me just do this part. But again, the important function here, the combination of functions, is this x e to the 2x. So x e to the negative 2x. So I want to take the derivative of this guy. We can use the product rule, right? And the product rule from calculus, the first part calculus, is x e to the negative 2x plus x e to the negative 2x, and you take the derivative of x, and then you take the derivative of that guy. So if you want to review, so the derivative of the product is, I remember it as fg plus fg, and then prime f prime g. So if we find this derivative, we get, let's make this a little bit smaller, we get, we have, let's see, well, the derivative of x with respect to x again is 1. But 1 times e to the negative 2x is just e to the negative 2x, plus x times the derivative of this guy, which we've done many times. And that's just going to be e to the negative 2x times negative 2. So we have e to the negative 2x minus 2x e to the negative 2x. So this is our first derivative. So x e to the negative 2x is this. So let me just maybe box this so we won't lose this. So that's our first derivative. So we have basically this part right here. It 4 times, and then we're going to replace it with this. But we need the second derivative, so let's take the derivative of this guy one more time. So we have, let's see, let me maybe move this here. So e to the negative 2x minus 2x e to the negative 2x. So I want to take the derivative of this guy. Well, this is just a difference of functions. Let's see, I'll work down. This is really e to the negative 2x, right? I can take the derivative, minus 2, and then x e to the negative 2x, and then take the derivative. All right, f minus g, right? If I take the derivative, it's just f prime minus g prime. So that's all I did. So that's the property. And well, this is pretty easy because we've done most of the work. What's the derivative of this guy? Well, we know it's negative 2 e to the negative 2x, and then minus 2, and then this guy, well, we already found the derivative, right? It's basically the yellow part above. So I'm going to copy the yellow part above. So I have e to the negative 2x minus 2x e to the negative 2x, right? It's basically that from above. And almost done here. It's not very difficult. It's just tedious. So we have negative 2 e to the negative 2x. We can distribute these guys, so 2e to the negative 2x, negative is positive, 4xe to the negative 2x. Okay, this is the second derivative. So we have the second derivative, we have the first derivative, and we got to plug it in to here, this spot, and this slot doesn't need it because there's no derivative. Okay, so let's try to be very careful here. I will expand this. I just don't want to. Okay, so for second derivative is negative 2e to the negative 2x minus 2e to the negative 2x plus 4xe to the negative 2x. That's the second derivative, plus 4 times the first derivative, which is the yellow part, e to the negative 2x minus 2xe to the negative 2x plus, and I'm going to move this because it's important that you see all of this, 4xe to the negative 2x. Okay, and that's hopefully going to give us 0. But I want you to see that, right, there's the second derivative, right, second derivative. There's a first derivative, right, or in yellow. And then, of course, this is the third term that there were no derivatives. Okay, so we're done differentiating. Now we just have to find the, now we just do some algebra. It's just combining like terms, right, distributive properties. So the first part, this looks nice. Negative 2 e to the negative 2x, negative 2 e to the negative 2x is negative 4 e to the negative 2x plus 4 x e to the negative 2x. And, whoops, I can distribute this 4. So I get plus 4 e to the negative 2x minus 8x e to the negative 2x. That's 2x plus 4x e to the negative 2x. Okay, combine like terms. Let's see, what do we have? We have negative 4 e to the negative, this guy and this guy, that's 0. And then this guy and this guy, that gives us 8x e to the negative 2x. But we have a minus 8x e to the negative 2x. So that does give me a true statement. Thus, y2 is a solution to the differential equation above. Okay, so tedious, but not very difficult. It's really just a big review of differential calculus. So hopefully that helps.